Hi everyone. So last time we talked a little bit about continental drift, what that meant. So today we have some evidence here of that theory. So in 1908, Ernest Shackleton's found that there was coal in Antarctica. So this might not seem like a really big deal, but the reason that this is really important is that coal only forms from some sort of vegetation that is buried by geological processes in warm, swampy locations. So as we know, Antarctica is not a warm place. So this is really important because it shows that with this continental drift, this movement of the land masses on Earth, Antarctica could have been in a region on our planet that, one, vegetation could form on, and two, that was in this warm, swampy location. So having that coal in Antarctica really gave us an insight of how these plates have been moving and how this has been affected. So let's define a few terms here. So lithosphere is a layer of our Earth that is part of our solid land. So our lithosphere is all of the crust of the Earth and a little of the mantle. And then our next term here is going to be the asthenosphere. So this is a semi-solid layer that is below our lithosphere. So lithosphere is going to be the large masses of land that are broken up into plates, and the asthenosphere is going to be what is going to allow these plates to move because of that semi-solid layer. It's more fluid than that lithosphere, and it's going to allow it to move move our plates. So our plates float on top of our asthenosphere, and there are more than a dozen different plates on our planet. So we have more than 12, but there are two types that are possible. We have oceanic plates, which are more dense, though sometimes they are thinner. And then we have continental plates, which are less dense, but usually a little thicker. So all these two types of plates and all the different types are broken into different parts. Another interesting thing is that we can have both a continental and oceanic plate. So there's different divisions. So if we have a plate where we have some land on that plate, that portion or that edge that has the land would be considered a continental plate, but the edge that has the ocean is going to be considered an oceanic plate. So it's really more about what is on the edges of those plates. And we're going to see that in a second. So if we take a look here at our North American plate, we can see that one edge is on our continental USA. So we can see here that this would be considered a continental edge, where if we look on the other side of this plate right here, this is ocean. So this would be considered an oceanic crust over here. But let's take a look at how these are moving. So these arrows are indicating how these plates are moving, which direction. So if we take a look, this North American plate is kind of moving up into that area. We can see that our Eurasian plate is moving in the opposite direction. Same here with our South American and African plate. But if we think about that, our Eurasian plate is moving kind of in an angle, but our African plate is moving towards that. And we saw a little bit with our videos yesterday, a simulation of what's going to happen here. Again, our Indo-Australian plate is moving up towards that Eurasian plate as well. So all of these different movements have some sort of meaning when we're talking about what's happening here in our area. So we're going to define what all these different plates mean in just next time. But you can really see how these arrows and this movement might affect what the planet might look like. So again, if we take a look, we see a few different terms here. the red lines over here are considered convergent boundaries. Our green lines are considered divergent boundaries. This kind of purpley color is our transform. And then we have something called diffuse. So if we take a look, there are different boundaries even on the same lines of our plates here. So if we take a look on the California side, that is a transform boundary. And I'm going to erase it just because there's red on our lines. But we have a transform boundary over here. But then if we keep going down the edge of that plate, it turns into a convergent boundary. And again, if we go up a little bit, we can see that's also a convergent boundary, but it turns back into a transform and changes. We can also see that happening here in the ocean. We can see differences between divergent and transform boundaries over here. And so what I'm trying to explain to you is that it doesn't need to just be one type of boundary. It really depends on the situation and how those plates are moving, which are going to define those different areas. It does not always need to be one type of plate boundary. It can be multiple in one area. So that's where we're going to end for today. If you have any questions, please feel free to reach out.